So looking at section 2.5, working with question 24, uh, the question mentioned the mean was 38,000 miles with a standard deviation of 2,350. So part B of this question kind of says determine, so we have the lifespans of three randomly selected tires, 35,650, 40,350, 38,000 miles. Use the empirical rule to find the percentage that corresponds to each lifespan. So the first question says the lifespan of 35,650. Now, the empirical rule is this graphic over here, which you can see in your folder in Blackboard. You can open up this document and you'd have this empirical rule. So the empirical rule is this bell-shaped curve. So the area under the curve is the percent. So the total area on the curve is actually what we call 100%. Now, notice that the mean, the sample mean in this case, is halfway across here. So if I go left of the sample mean, 50% of the data is to the left of the mean, 50% of the data is to the right of the mean. We'll also pick up on is if you move one standard deviation to the left, that's right around 34%. If you move one standard deviation to the right, that's about 34%. So in other words, 68% of your data is within one standard deviation from the mean. If you go two standard deviations, notice that 95% of your data is within uh, two standard deviations. And if you go three standard deviations, then basically you're almost all the way out here to the very end. So like almost all of the data, 99.7% of the data is within three standard deviations. So this is the empirical rule. These numbers here, 68%, 95%, 99%, 99.7%. So in our problem, they gave us the mean to be 38,000. And they said the standard deviation was 2,350. So if I add 2,350 to, let me see, get my pen to work here. If I add 2,350 to 38,000, we're going to end up with 40,350. If I add 2,350 again, we're going to end up with 42,700. And if we do it a third time, we're going to get 40,050. Now, if I move to the left of 38,000, so if I subtract 2,350, we're going to end up with 35,650. If we subtract 2,350 again, this puts us at 33,000. And if we subtract 2,350 again, we're going to end up with 30,950. So again, we're talking about this bell-shaped curve. So usually it kind of bends at this one standard deviation. So it kind of starts down low, goes up high, bell shapes around. So, and then it kind of comes back down over here. So you have to forgive me on my drawing, but 100% of your data is under the curve. Now our question is, we're talking about percentiles. Our first one says, what percent of our tires have a lifespan of 35,650? So let's say 35,650 would be here. So percentile, what they're talking about is the area to the left of this 36,250. So they want to know what percentage of our tires get up to 35,650. Now notice that 34% of your data is over here, and 50% of your data is left of the mean. So if we go 50 minus 34, if you will, so if we go 50% minus 34%, that's going to give us 16. So 16% of your data In other words, 60% of your tires are going to be in that percentile. So 16% would be here. So I don't know if I have the percent symbol. You may have to just type in the 16, the percent symbol may already be there. The next question is, what's the lifespan of for 40,350 miles corresponding to the percentile? So what we're asking is, what percent of our tires reach a lifespan of 40,350? So 40,350, so if I erase this and start fresh, so looks like I lost part of my graph there. Let me get that back in here. So 40,350 would be over here. So the percentile is the area from here all the way over to here. Now notice that from here, from the left up to 38,000, that's half of the data. So this is 50%. Notice that the 40,350 is only one standard deviation from the mean. So based on our empirical rule, 34% of our data is in one standard deviation over here. So if you had the 50 and the 34%, we're going to end up with 84% of your data is going to be at 40,350. So the next one thing says, what's the lifespan? What's the percentile of tires that make it to 30,000? So notice how 30,000 is the mean. That's halfway across. So that would be 50%. So using the empirical rule, half the data would be left of the mean and half the data would be to the right of the mean. So 50% of your data would be the percentile. So 50% of the tires make it up to 38,000. Okay, so those are your answers to those is you kind of use the empirical rule as a shortcut. We don't actually have to use the z-scores here per se yet. We will use these scores later on, but we can just use the empirical rule since those numbers fall nicely on our graph.